So what I'm going to do now is basically walk you guys through Lab 1, but with a different sample than what you have in your lab packet. So you'll be seeing how to answer each question, but your answers will be different because you'll be working with a different binary. So the first step is to extract the file and then run the file command on it. So we're going to launch our File Explorer by clicking on Activities in that upper left corner and then clicking the File cabinet. I've already copied it here. I have it in Documents, Sci-Fi, Demos, and there it is sitting right there. For you guys, drag and drop usually won't work from a Windows host to a Linux guest, but right-click copy, right-click paste typically will. So now we're going to navigate to the same directory in our command line using the change directory cd command. So we'll cd to Documents, tab complete there, Sci-Fi, and then Demos. And we can ls and see it sitting right there. Now, as in the slides, we're going to unzip this using 7-zip, so 7z space x for extract for people who can't spell, and then evil.7z. Going to ask for a password. Everything's encrypted with the password malware, all lowercase. For security, that's not going to actually be echoed, so it doesn't look like you're typing anything, but you are. And then you can see we have our evil sitting right there. Now evil doesn't even have a extension on it right now, and so let's run the file command on it and see what extension it should have. So we'll just type file evil, and there we see it's a PE32, so a 32-bit portable executable file compiled with Intel 8386 for Windows. So if we wanted to give it the proper extension, we'd use the move command. So we're going to move the file evil.exe move the file evil into the file evil.exe. And now it has an extension, which doesn't really matter for Linux, but it makes me happy. So the next question is, what is the SHA-256 of the file? So we're just going to do SHA-256 sum evil.exe, and there's our answer. SHA-256 is one of those neat commands that you can pass a star to. So if you wanted the SHA-256 of everything in the directory, you just star it, and it would recursively, or actually it's not recursive, but it would give you the hash of everything in your directory. All right, how many DLLs does it import? Or actually, you can do this in Linux, but we're going to move over to Windows World. So here's my 7-zip over here. You can generally drag and drop between a Windows host and a Windows guest, so it's simple to get that. We're just going to right-click, 7-zip, extract here. It's going to ask for a password, malware, and then there's our file. So the tool that we talked about to do a lot of our static analysis is this Chili Pepper CFF Explorer. It's an old tool, but still extremely valuable, and we'll just drag and drop evil.exe into it. Now, to figure out how many DLLs there are, we're going to want to look at our import directory. So we'll come over here, we'll drag this down, and we can see it imports functions from 4 different DLLs. Your answers, again, with your own sample, will vary. Find an imported function that accepts an ASCII string as a parameter. So this is really just a question of your understanding of the slides. And some of the naming conventions that we talked about. So the functions that take ASCII strings end in A, whereas the functions that take Unicode or wide strings end in W. So any one of these functions would suffice to answer that question. Identify an imported function that's an expanded version of an old function. Again, we talked about when we were discussing naming conventions that the imported versions end in X. And so let's see if there's one in this binary. There it is. So you actually have 2 suffixes on this one. So this is telling you that regSetValueX is an expanded version of the original function regSetValue, and it's also telling you that this particular version of the function takes an ASCII string. What domain is included in the strings of the binary? So there's a few ways we could answer this one. You could go over to Linux, go back to your Linux box and run strings, but I do try to get you guys into IDA as soon as possible so that it's less intimidating. So we're just going to use IDA to run strings. So I'm just going to drag and drop evil.exe into the IDA icon. You're not going to be able to talk anyway. You're in an isolated network. And we'll just hit OK. The shortcut to launch your strings tab is Shift F12. Sometimes you might have trouble with your virtual machine actually catching your shift commands, so you can also go to View, Open Subviews, Strings. And there are strings. In this particular sample, I don't believe that we have a domain sitting in here. The sample's domains are actually all encoded, but you can see some of the strings that we have, including the names of some of the imports we just looked at. What non-system file name is identifiable in the strings? Again, that's going to be encoded in this sample, but we do see some file names that give us some hints as to functionality. We see a DLL name, we see cmd.exe, which indicates it might actually attempt to interact with the command line, especially since we see this path up here. And so we get some hints as to the functioning of this program from its strings, but it does encode its most valuable strings. And then another strings question. All three of those questions for you guys can be answered by looking at strings. 4, actually. So we're going to skip down to question 10. There's something suspicious in the resource section of this binary. What are the first 4 bytes? Well, we looked at the resource section. Again, there are a lot of ways, but we use CFF Explorer. And I suggest going down to the resource editor, not this resource directory, resource editor down here. And we can look at our resource section, and we too have something strange in the resource section of this binary. And so the first 4 bytes for my sample would be those guys, 697E4800. Your answers will vary. We actually have 2 strange resources, but it just happens to turn out that their first 4 bytes are the same. That's not coincidental. And then the only other resource we have in here is the standard configuration file, the manifest. If you wanted to save that resource, which you will have to do in a later lab, you can just click on it, right-click, Save Resource Raw, give it a name, and I'll just slap it on my desktop. And then you end up with this resource saved all by itself. And you could open that in a hex editor or any other environment. So that is it for Lab 1.